So whenever I think of this section, 3.5, derivatives of trig functions, I always think of an inverse pyramid that's sitting on its head. And we start out pretty simple and it gets a little more complicated. And we're right about here. And then it's not like this. It's actually insanely more complicated. It just starts out, it's not too bad. Well, okay, now it's getting a little more complicated. And suddenly, bang, things get completely out of control. So get this down. Lock this down. Because if you don't, you've got problems, right? So we've shown this one by graphing. Here is sine of x, and here's the slope. Slope is 1, slope is 0, slope is negative 1, slope is 0, slope is 1. So what's the derivative of sine of x? Derivative, incredibly pathetic. Derivative of sine of x is cosine of x. All right, you can do this algebraically. So we look at the limit as h approaches 0 of cosine of h minus 1 over h. Plug that in your calculator and you find out it's 0. And then you find out that that whole sine of alpha plus beta, you can rewrite it as sine of x cosine of h plus cosine of x sine of h. And I was going to leave it for you, but I honestly don't know if I can do this. I thought it'd be fun. So this is sine of x plus h minus sine of x over h, which if we blast this out, we get and then we can factor out a couple terms and bust out the h separately and leave whatever's left over. I'm breaking the h out into separate pieces because that's what I do. Plus so we know this one is 0 now. So this term's going to vanish. And we know sine of h over h is 1. So we're just left with cosine of x. That's back in the day, sine of x over x, if you recall, sine of h over h. All right, what about cosine of x? Well, here's something to remember. All c's are negative. At which point you're probably like, I beg your pardon? Well, d dx of cosine of x is negative sine of x. More on this in a little bit. All right, so let's just try some examples. Derivative of this. So y prime equals, and notice I called it u here just to mess with you. Leave the first one alone. Cosine of x. Derivative, leave the second one alone. Can I factor this more? Sure. Why would I? That's it, it's done. So how about du dx? I could have called it u prime. Low d high minus high d low. Derivative of sine is cosine, but there's a negative there. Equals, let's see, negative sine of x plus sine squared x minus minus plus cosine squared x. Sine squared plus cosine squared is 1 minus sine of x. And this is the kind of math you would be expected to do on an AP exam. Fair amount going on there, but not the end of the world. All right, let's jump right to applications. Last time we did derivatives and then application, separate unit. Now we've got this silly little experiment where you hang a weight, also known as a bob. It's not named Bob, it's called Bob. And you pull it down, it bounces up and down. All right. So that's the motion. You pull it down to start. You could push it up, but it's usually pulled down. And they say the position is 5 cosine of t. So S of t equals 5 cosine of t. Therefore, the acceleration is -5 sine of t. And then the acceleration, -5 cosine of t. So you'll learn to do these. You'll learn to get relatively quick at them. And for another great moment in calculus, we discussed jerks. No, seriously, that's what a jerk. It's the third derivative up here. It's the derivative of acceleration. So the change in acceleration, the slope of the acceleration, right? The jerk is going to be S1, 2, 3 of t. This is what causes motion sickness. All right, regular gravity is a constant pull. Gravity is just that. You're in a car and you start jerking left and right. Remember that acceleration is a vector, so it's not necessarily acceleration. It's also change in the impact of acceleration, the direction of acceleration. So what's the jerk caused by the constant acceleration of gravity? Well, we know that acceleration is -9.8 meters per second squared in metric world. So a prime of t, there's no variables in here, it's just 0. That's why gravity does not cause that. What's the jerk of the harmonic motion? Way back up here. All right, that's the third derivative of the position, or the derivative of the acceleration. Yeah, it gets boring pretty quick. And not even boring, just like insane. It just gets crazy. All right, so what's the derivative of tangent? Well, you can figure it out. And I don't actually have this memorized. I probably do now because I haven't taken a full 3 months off of calculus. But you can always just derive it pretty quickly. Low, b high, minus high, d low, over low squared. Well, that's cosine squared. That's sine. Grr. That's sine squared. The negatives cancel, so we get 1 over cosine squared, which is secant squared x. And you got to memorize it. You got to memorize it. Notice again, c negative, secant, which is 1 over cosine. So you do this whole cosine of negative first thing, and another c negative. These have to be memorized. You're going to use them so often they'll become second nature. And quite honestly, I don't see these that often. But I mean, it's not that hard. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Derivative of cotangent is negative cosecant squared. Derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. All right. So here we go. Now we start to give you the problems you're going to see. Use Ender to figure this out. Bend lines of tangent normal to the graph at x equals 2. Well, we need the point, so we're just going to call it tangent of 2 over 2. And I could get you a decimal in that. It's not really equals 2 comma negative 1.093. All right. So if I do Ender, of tan of x over x comma at 2, so the function with respect to x at 2, I get 3.433. I will show you that because I am sure you're dying to see it. Math 8, derivative with respect to x, alpha. I'm a big fan of my, hopefully I have to go check. It should be in function, but I was checking more for radian. Second, quit. It should still be there. Nice. Cool. Tangent of x, close that parenthesis, over x with respect to x. Oh, it's going to be t, for crying out loud. We'll see what happens. Exactly, because I'm no longer there. Yeah, I'll just do it from scratch. Math 8 x fraction tangent x. Oh, for the goodness sake. I always look at just the keyboard and I have to look back and forth. Alpha y equals tangent x. And that's wrong because we wanted it 2. Done. 3.433. Hey, look at that, 3.433. Shocker. All right, find the lines are tangent normal to the graph. So tangent y minus this number, or y plus 1.093, equals 3.433. X minus 2 would have been plus, now it's minus 1.093. And normal, y equals -1 over 3.433. This is more than acceptable on a test. Why take the risk that you're going to make a mistake? Simple, simple. By the way, you could always, excuse me, you could always graph these and see if they make sense. Graph this, and go to that x equals 2 points, see if these lines make sense. That's it. So let us practice. And I think we're getting to something called chain rule, but we're going to try and avoid it because that's coming up next unit. All right, y equals secant of x. Y prime equals, according to up the top, secant x tangent x. Y double prime equals, leave it, secant of x. Derivative of tangent of x is secant squared x plus derivative of secant x is secant x tangent x tangent x. Looks horrible. Just take some practice. This is exactly what you will do all year long. Crazy, crazy, crazy math like this. And it's actually one of the big reasons I recommend taking the class. If you can do AP, BC Calc, and get yourself a 3.45 on the exam, you can really do anything. Because I mean, it's crazy. So good luck, happy mathing.